on data acquisition from Arduino to the web. Please welcome Mario.
Thank you. This talk is about real-time data acquisition. I had to squeeze my speech to respect the time slice assigned. So I do apologize for not accepting questions and also for not introducing myself properly. I might fix this at the end of the talk if time allows. Also, spoken English is a bit of a problem for me, so I will speak slowly, and I do apologize for that too. Let's start by supplying some context. A simple and fairly typical situation is represented in the picture above, where we have a device connected to a sensor which measures a physical value, transforms it into a number, and this number has to be sent to a remote server where it will be stored or elaborated in some way. We will use Python and Redis to build an effective solution for this domain of problems, starting from this very simple case. In the second picture, we see a slightly more complicated but also more realistic situation in which we collect data from many different independent devices. And in a third and final scenario, we also add one or more servers, maybe for supervision or backup purposes. The communication pattern we will use is called publish-subscribe, or PubSub for brief. I'm sure most of you already heard of it, so I will quickly summarize how it works with just enough details to follow the discussion. The peculiarity of PubSub is that the two speakers do not talk to each other directly, but they rather interact by means of an intermediate service called message broker. The sender transmits the information to the message broker and doesn't care about what happens afterward, in a manner sometimes called fire and forget. On the opposite side, we have the recipient, which expresses its interest in receiving the information with a sort of registration called subscribe. The role of a message broker in the middle is that of keeping track of a list of active subscribers and broadcast to them all data as soon as received. The message broker doesn't provide any kind of retention or retransmission, so all information published while a subscriber is not active is actually lost. I think we know enough about PubSub to start using it. But before digging into the code, let's ask ourselves a question. Is it worth it? I mean, in respect to a simple point-to-point connection, do we really get an advantage? If you look at this picture, this is not obvious at all. After all, we are going to use 3 components instead of 2. So where is the deal? I will come back to this question later after we have practiced some working examples, and hopefully with a positive answer. So let's start with a simple publisher. The process I'm running on the left represents our device. It produces a sinusoidal value and transmits it. It's interesting to note that even if nobody is listening, the process doesn't care at all. It keeps doing its job with no problem. I think this is already remarkable. I said that nobody is listening, but this is not completely true. The publisher is already communicating with the message broker. We just don't have any active subscriber yet. So let's run one. As expected, data is now flowing from the publisher to the message broker, and from here to the subscriber. So let's move to the code. This is the publisher code. Here we have two duties. First and obvious is to obtain a connection. In this example, I happen to use a library called the Redis Pi, which is a client Redis library. We have a couple of ways to produce a connection. After obtaining the connection, we enter our transmission loop, where we produce a sinusoidal value. We build a string by repeating equal characters, so the information is actually the length of the string. And finally, we transmit it to the message broker with this publish command. The first parameter, channel, is a name for a discussion topic. For us, it's just a constant string. So as long as publishers and subscribers agree on this, we are fine. You just have to pick up one name. The purpose of this parameter is that if we needed to manage more independent communication with a single server, we could use different channels. The second and more important parameter is the data itself we are sending. Here we don't have many choices. It's not a number, no lists, no rich data structures. It's just a string. It has to be a string. As we will see later, this is not a real limitation, as we can always serialize, for example, with JSON, our information, and the resulting string will be conveniently deserialized at the destination. If we move to the subscriber, here we have one additional step. After obtaining the connection and before subscribing, we also need to obtain a specific object called PubSub. The reason for this is that when the process enters a subscriber state, the subset of Redis commands available is restricted. So the library expresses this constraint by providing us a suitable interface. We finally enter the receiving loop, where we collect data with this listen method. Listen is a blocking method, so our process stops until some data is received, and this is the most efficient way to implement a subscriber when its sole purpose is to collect data. We also have a non-blocking alternative, which I show in a minute. Here I'm using getMessage instead of listen. GetMessage returns the message if available, or none if not, so you can do useful things in the meantime. So, now the fun part. Let's check if, as I promised, we can use the very same solution in different situations as well. So here on the left, I will run some more publishers. It's the same code. And on the right, I will run another server. As you can see, everybody talks to everybody. In my opinion, this is remarkable, because if you think about it, in no way we had to over-engineer our original code in order to obtain later on this kind of flexibility. How is this possible? If I go back to my previous question, I do believe this is the most remarkable benefit of PubSub. All actors in the communication just need to focus on their own duty. The publisher publishes, the subscriber subscribes, and nobody cares about what happens next. Under the hood, we have a message broker which orchestrates all this communication for us. A second advantage is that we need a much reduced number of connections. Let's count them. With PubSub below, we need one connection for each publisher plus one connection for each subscriber, and the total number is given by the sum of this. If we use the point-to-point connection, we would require one connection for each sender-recipient pair, that is the product. And these two numbers diverge very rapidly by increasing the number of devices or servers. So let's go back to the code. We have seen a very simple script. I would say a naive solution, which is useful mainly for demonstration purposes. However, as we are delegating so much headaches to the message broker, we are not far from obtaining from here a robust and production-ready code. The main limitation we have to remove is the vulnerability to connection errors. Let's do it. This is the improved publisher. And what I do mainly is that in the transmission loop, I catch an exception, and if it is due to a connection error, I restore the connection. The connect helper function is itself a loop where I try to connect, and failing that, I try again later. Please note that I'm pausing for a while between two retries. I stress this as it is possibly the most important instruction in this script. If we didn't pause, whenever the server is not available, we would enter a so-called busy loop with a lot of activities going on for nothing and a significant waste of resources. I also took the chance to add some option on the command line, and in particular this JSON switch, which is used to simulate the transmission of multiple signals, which is a fair common need. When the switch is activated here in the transmission loop, we produce a list of three values, which are enclosed in a dictionary together with a timestamp, and the dictionary is JSON serialized, and it will be deserialized at the destination. It's always a good idea to collect the timestamp at the source. You could reconstruct it at the destination, but in doing so, the time series would be affected by an approximation due to the latency of the network, and sometimes this might be inconvenient. So let's see if this works. I will replace the publisher below with the improved one, and the same for the server. Now, my preferred way to simulate communication error is to unplug an Ethernet cable, but being localhost, I will stop the Redis server instead. As you can see, everybody stops communicating, but the two processes below start immediately to complain and to log errors. And if I restart Redis, they hopefully recover. OK. So we now move to a specific use case. Here, we would like to collect data from Arduino or any other embedded board with limited software support. If you check on the Redis site, which I did for you, hopefully, yes. You will find a long list of client libraries available for many different programming languages. I'm sure you can find support for your language too. I mean, unless you program in COBOL or Fortran. And see, is obviously included, so there are many options. I happen to use this iRedis one. So what's the problem here? The problem is that due to their completeness, this library have a list of dependencies, and it might be very difficult, if not impossible, to recompile them in a limited environment. So we need to find another way. And the solution I suggest is to inspect in detail the protocol used by Redis, which is called REST, I think. And once we have done it, the solution will be trivial. So Redis CLI is an interactive client which comes with Redis. Here, I'm running it on an arbitrary port to issue a publish command. We need the publish keyword, followed by the channel, and finally, our data. And nobody's listening here, but for example, I could use the netcat utilities in listen mode to inspect what's happening. I reissue the command. Can you read it? So what is this? It's a text of multiple lines. In the first line, we declare the number of expected tokens, then follow the tokens, each one preceded by its own length. It's not a big deal. Certainly, we don't need any fancy library to manage this. As long as we are able to concatenate strings and we know how to open a TCP socket and write to it, we are fine. And that's what I did here. I removed the dependencies on Redis Pi and used the native socket module instead to open at low level a socket. And the command has been prepared using basic string manipulation. And it just works. There is also a library for Arduino which does exactly this thing. Here we have begin to open a connection and publish to publish. It's interesting to note that the set of commands is rather limited, and notably subscribe is missing. I have no idea how difficult it would be to implement in this context subscribe, but for once we are lucky, because for us Arduino is the publisher, so publish is all what we need. And here it is. It's not different from what we have already seen in Python. This technique of inspecting the protocol can be useful to interact from Arduino to Redis for many different things, because Redis does much more than PubSub. So just a note. Okay. A final use case I would like to share is this one. I start from the result in case I run out of time. If some of you could please use a smartphone to connect to this URL, you should receive some data. And this data comes from a PubSub publisher. So what are we doing here? Our purpose is to deliver data collected from PubSub to a remote web client, which can be a browser, a smartphone, a tablet, and obviously this use case has many practical applications. How can we achieve this? Well, if we could subscribe a PubSub channel from client-side JavaScript, we would have done. And this was also my first thought. So I did some research on Stack Overflow and other places, And the result of this research is that no, it's not possible. So as long as I know, we can't go this way, and we have better to find another solution. And the solution I'm proposing is server-side. Basically, what we do is we provide a web page where a WebSocket connection is established. So the server has some channel to write back to the incoming web clients. Then, on the server, we run a second background process, much similar to the listener we have seen before. So we already know how to subscribe a PubSub channel there to collect data. Upon receiving data, we just write them to the WebSocket, and so this is the basic idea. Let's see this in action. So, on the server, we need two things. A web server. I used Django for this. So here, every time a web client visits our endpoint, a WebSocket connection is established. Then on the server, we write our repeater, because we are using a listener as a repeater. I implemented it as a Django management command. Okay, and finally, we run a publisher, which is our device. So as you can see, data is flowing from publisher to message broker, from here to the subscriber. And from the subscriber, I'm using Django channels to ask him to broadcast this data to the web clients. So what we see on the top is the log of the consumer. In Django channels world, the consumer is to WebSocket what a view is for HTTP. And this data is received by the client. It produces an error because it doesn't recognize it, because it expects a JSON time series and is receiving a raw string. But we can correct this by using our JSON switch. I also slow down to better see what's happening. And this time we are receiving this JSON encoded time series that go to a web client. I have 1 minute to introduce myself at the end, as I promised. I work as a consultant in Italy. When I started my job, Stack Overflow was not available, but it was not a problem because a C++ compiler was all what you needed to solve any problem, and it was very nice, and I enjoyed very much and was really comfortable. But unfortunately, for some reason, the world moved his attention to the web, so did I, and this forced me to use other technologies. I started with PHP for a very short period of time, and then used Plone and Django. I'm not using Plone anymore, but it has been very informative and inspirational to me. And more recently, I'm trying to mix these two experiences and provide web technologies in the automation field. And the main technology I use are summarized here: Python, Redis, and Django channels. And this is These are my references. I would be more than happy to interact with any of you. And thank you for listening.
Thank you very much, Mario. Hopefully the first of many presentations.